and welcome to Code Disclosed. In this video, I will explain the idea behind dot or scalar product of two vectors, what are the two main definitions of this vector, and how we can implement this in MATLAB. So let's get started. Let's first explain the difference between a scalar quantity and a vector quantity. A scalar quantity is a quantity that has only a magnitude. As an example of this, speed. Speed is simply how fast you are traveling. So if we have a car, we can say that this car is traveling at a speed of 20 meters per second. However, for a vector is a quantity that has both magnitude and direction. As an example of this, velocity. Velocity is a speed in a given direction. So for a car, we can say that this car is traveling at a speed of 20 meters per second to the east. So adding this bit of direction allows us to express or represent a vector quantity. All right, so this is the difference between a scalar and a vector quantities, which will be very helpful later on in the video. All right, now speaking of vectors, how can we represent vectors or express vectors in coordinate systems? One of the coordinate systems we have is the Cartesian coordinates. Cartesian coordinate system has three axes, x, y, and z, and three of them are perpendicular to each other. So if we have a vector A, for example, and I want to represent this vector inside this coordinate system. To do this, we need to do projections onto these three axes. So a projection on x, a projection on y, and a projection on z. And see where these projections hit these three axes. So for example, this projection hits the x-axis on this value. So we can say that ax is how much of a is on the x-axis. We do exactly the same thing on y. So this is the projection and it hits y-axis on this value. So from 0 to this value is how much of a is on this y-axis. And it's exactly the same thing on z. So this is the projection on z and this is where it hits the z-axis, and this is how much of a is in the z-axis. So one way to write or express vector a is by using these coordinates, so ax, ay, and az. Let's use numbers now. So you can see here that for the x-axis, the projection hits the x-axis at 5. So we can say equals 5, and on the y it hits also 5, so it's another 5, and for the z it hits on 4, so it's 4. So you can write it as equals to a bracket, two brackets. And inside you have 5, 5, and 4, and you need to write them in order. So x, y, and z. The coordinate on x, coordinate on y, coordinate on z. There is another way actually to represent vectors in the Cartesian coordinate system, which is by using the unit vectors. So unit vectors are vectors which are tangentials to each of these axes, and they have the magnitude of 1. So for the x-axis, we have the unit vector of I, and you can see here that I has a magnitude of 1 on the x, but 0 on the other two axes. On the y, we have j, and also it has y on the y-axis, and 0 on the other two, and the k is on the z-axis, and it has magnitude of 1 on the z-axis, and 0 on the rest. So we can represent vector a as a function of these unit vectors by saying ax, which is the coordinate of a on x, times I, which is the unit vector on x, plus the coordinate of y times the unit vector of on y, plus the coordinate on z times the unit vector on z-axis. Let's put numbers here. So we know what ax, ay, and az are, so we can put them like this, and you can notice here we have pluses, so you have 5i plus 5j plus 4k, and this is how you represent a vector using unit vectors. These two ways of representations are totally equivalent, and it's totally up to you which one to use to represent vectors. All right, what if we have another vector? So this is my A, if I have another vector which is b, I'll do exactly the same thing. I'll do projections, and I'll check where these projections hit these three axes, and I'll get the coordinates of this vector. So I can see here that for the x it hits on 6, on y it hits on 3, and on z it hits also on 3. So I can say equals to 6, 3, and 3. All right. Now the question here is, how can we know the amount of vector A that goes in the direction of vector B? In other words, how much of A is there in B in the direction of B? The operational or the mathematical operation that allows to answer this question is the dot product between these two vectors. How to calculate the dot product? Dot product can be calculated by this equation. So A dot B, means the dot product between A and B equals to, these vertical lines means that I need to take or I calculate the magnitude of the first vector times the magnitude of the second vector times cosine of theta. Now theta is this one, which is the angle between both vectors. So the multiplication of the magnitude of the first vector times the magnitude of the second vector times the cosine of the theta between these two vectors will give us the dot product between these two vectors. Just as a reminder, this is how you calculate the magnitude of a vector. So it's a square root of the sum of the squared of the coordinates on each axis. For B is exactly the same thing. And remember, this is a dot product. This is a scalar product. What does that mean? It means that the result of this multiplication or the result of this equation, it's always a scalar quantity. It's always a number. It could be positive, it could be negative, it could be 0, but it's a scalar number, not a vector. All right. Now, we have another definition for the dot product or the scalar product. And this definition, the second definition, uses the coordinates of both vectors. So for example, this is the first definition that we have been introduced to, and this is the second one actually. So the second one is the sum of the multiplication of the coordinates of each vectors on each axis. So you have ax bx plus ay by plus az bz, and this will give us the dot product between these two vectors. You can see here that the left hand side of these two equations is exactly the same thing. So you can equate these the right hand sides. So you can say that this side equals to this side. Usually we use this equation when we want to know the value of the angle between both vectors. So we can say that theta is the inverse of the cosine of the left-hand side divided by this bit here, as we are going to see in a minute. All right, so speaking of theta, now if the theta between these two vectors lies between 0 and 90, the dot product of these two vectors is always a positive value. Always. Now, if the theta is an obtuse angle, which means that it lies between 90 and 180, then the dot product between these two vectors is always a negative angle. However, if these two vectors are perpendicular to each other, which means that the angle is 90, then the dot product is always 0. All right. So how we can code this in MATLAB? So let's move to MATLAB now, just to show you how we can show this and code this. So as usual, we start the code by close all. That closes everything, all the plots or figures opened. Clear all. It will clear all previously assigned variables. And CLC, it will clear your command window here. To make it easier and to declutter the codes you have, or declutter the screen you have. As you can see here, I have 3 pairs of vectors, and we are going to check the dot product and the angle between and the angles between these 3 pairs. So let's uncomment the first pair. I have A and B here. And let's first calculate actually the dot product. And I'll say dot equals to. So let's calculate the dot product here. Since I don't have the value of the theta or the angle between these two vectors, I only have the coordinates of these two vectors, then I can use the second definition. So I can say A1 times B1 plus A2 times B2 plus A3 times B3. And this will give me the dot product between these two. So let's run and see what the value will have. So let's say dot, and it's 67. It's a number, and it's a positive number. So remember, when you have a positive dot product, then without even calculating the angle, you should know that the angle between these two vectors is an acute angle. Well, actually, let's make sure that it is an acute angle. So first, I need to calculate the magnitude of A. So I can say A norm equals to SQRT of A1 squared plus A2 squared plus A3 squared. That's the magnitude of the first vector. So let's calculate now the magnitude of the second vector, which is B. So B norm, I'm gonna write, so it's a SQRT of B1 squared plus B2 squared plus B3 squared. And once I have this, I can calculate the angle between A and B. So theta here is the inverse of the cosine, A cos in MATLAB, the inverse of cosine of the dot product divided by the A norm times B norm. So basically here I used the first definition of the dot product. Now MATLAB here will calculate this angle in radians. So just for an easy interpretation of this angle, I will convert the angle to degrees. So theta degrees is, I will use the rad.deg command of theta. It will convert from radians to degrees. So I'm not going to end this line of code with a semicolon because I want to see the value or the result on the command window. So let's run this and let's see what the theta between these two vectors are. I think I have, okay, so this is wrong here. Okay, so the angle is 9. So 9 is between 0 and 90, which is a very acute angle between these two vectors. All right, so this is how you calculate the dot product and the norms between, and the angle between two given vectors. Just as a side note, there is in MATLAB a built-in commands that will calculate dot product and the magnitude of vectors. So let's comment this and let's write dot here is the dot between A and B. So if you write the dot command, small letters, dot between A and B, MATLAB will give you the dot product between A and B. That's it. And here, instead of writing SQRT of all of these, in MATLAB you can say, okay, let me comment this and I'll say A norm equals to, you can say only norm of A. It will calculate the magnitude of vector A, and I'll do exactly the same thing here. So it's norm equals to norm of B, and I'll comment this. Yeah, that's pretty much it. Let's run it and see if we get exactly the same angle. So here we have 9.6. So let's run this again and we get exactly the same angle. So it's up to you whether you want to write the dots product or the norm or the magnitude by hand, or just use the built-in commands in MATLAB. Let's check the other two pairs, actually using exactly the same steps here, and let's see what the angle between these two vectors are. So for the second pair, the angle is 120. So 120 is more than 90, so, and it's an obtuse angle. All right, and the dot product, let's check the dot here. Is it a negative? It is a negative value. All right, so let's check the final pair, actually, just to see what we get. So the final pair, let's check the theta first. So the theta is 90, so they are perpendicular to each other. And the dot product here, it should be 0. It is 0. So, so this is how you calculate the dot product and the magnitude of vectors and the angle between any two given vectors in MATLAB, and hopefully it's helpful. I will include the link of the GitHub link for this code if it's helpful. And if you have any other way to code this, please let me know in the comment section. Thank you very much, and I'll see you in the next video. Thank you.